Hello everyone. Let us now discuss how can we solve this problem. Count subarrays with score less than k. So as we are given with score is nothing but product of its sum and its length. So score of an array is defined as the product of its sum and its length. Let us see an example. If this is an array, let us see what's the sum. 5 plus 4 9 plus 3 12, 12 plus 2 14, 14 plus 1 15, and the size is 5. So 15 into 5 will be 75. Given a positive integer array nums and an integer k, return the number of non-empty subarrays of nums whose score is strictly lesser than k. A subarray is a continuous sequence of elements within an array. So let us see what are those subarrays which we got valid, and the sum of the elements and the size. So the product of the sum of the elements and the size is strictly lesser than k. Now let us see. What I think is, first let us apply brute force. Even though it doesn't work, let us see how do we get the subarrays. Now I'm just taking 2, 2, 1. Let me write 2, 1, 2 comma 1 comma 4. Now 2143, I'll just copy that. 214 and then 3 and then 5 and then 3 and then 5. So here I have 5 subarrays with this, but I'm gonna ask you that 2 plus 1 is 3, 3 plus 4 is 7. Okay, it's perfectly alright. 2 plus 1 is 3, 3 plus 4 is 7, 7 plus 3 is 10. Okay, from after here, it is 2 plus 1, 3, 3 plus 4, 7, 7 plus 3, 10, 10 plus 5, 15. This is not valid. And I can't even say that this is valid. Why? Because the sum I know is 10, but the size, if I multiply it with it, so 10 into 4 will give me 40. So which is exceeding the limit of k. Now what is my intuition is to take the subarray only when the sum and the product will be lesser than k. So nothing but the sum, the product of the sum and the size will be lesser than k. So that's the intuition here. Now I took just 2. 2 into 1 is lesser than k. So this is valid. 2 plus 1, 3. 3 into 2, 6 is valid. Now 2 into 1, 2 plus 1 is 3, 3 plus 4 is 7, 7 into 3 is 21. This is not valid. Let me not take it. Now you might say, or imagine you are taking from 2, 1, 4, and then you might ask me what if I took 3. So here the nums of I will be from 1 to 10 power 5. But if there is something like this minus or in negative values, if nums can be, so we can take the next element, consider the next elements. But I am stopping here. Now I am taking 1 with 1 comma 4, 1 4 3. Now let us see. 1, wait a second, 1 4 3. So 1 plus 4 is 5 plus 3 is 8 into 3 is 21. I am not taking it. 1 plus 4 is 5 into 2 is 10. Now these two are valid, right? Now let me start with 4. Okay, 4 into 1 is 1, so it is valid. 4 plus 3 is 7 into 2 is 14. I am not taking it. Now I am starting with 3. 3 is already valid. Now 3 comma 5. 3 plus 5 is 8 into 2 is 16. I am not going to take it. So I am just taking 3 and I am going to 5. Can I take it? Yes. Now let me count what are the number of valid elements, right? Actually, I think there is something 5 into 2 is just, I think I got something error, right? 2 and 2 1, 1 and 1 4, 1 plus 4 is 5 into 2, which is not, yes, which is not lesser than k, right? It should be lesser than k, not equal to k. So 1 plus 4 is 5, 5 into 2 is 10. So I am getting a wrong answer for that. So that's my mistake, right? So I got totally 6 subarrays which are strictly lesser than k. That means the operation something like the sum into size, the sum of subarray elements and the size. Uh, the product of the sum of elements and the size is lesser than k. So the answer is 6. But just I need something like whenever I got an answer, something like subarray problem, I'll do a sliding window operation. But I am just starting here, right? My left or and the right one is here. Now, let me see what is the product. The product is 2 into 1, which is just 2. Now what I'll do every time is just expanding. I need to know the logic when to shrink. When to shrink. I think when you are using a sliding window, you need to just know when to expand, when to shrink the window. Now I'm just simply expanding. Now, okay, when I was here, the product was 2 and the answer will be incremented, right? Answer is 0. The product is 2, which is lesser than k. So I am incrementing the answer. Now the product will be changed, of course. Now I am taking after this. So 2 plus 1 is 3 and the size is, how do I get the size? I'll tell you in the algorithm. 2 plus 1 is 3, 3 into 2 is 6. Now if I incremented it by 2, I'll tell you what will it happen. Now I incremented it just by 1, just I incremented it by 1. Now only when I got the subarrays product, that means the product only greater than or equal to k, then only I'll shrink the window. I am considering it. 4 plus 1 is 5 plus 2 is 7, 3 is 21, which is greater than or equal to k. Now I am decrementing or shrinking the window. But if you see, do you ever got this window till now? I think we missed it. 4 plus 1 is 5 into 2 is just 10. Okay. Is it greater than k? Yes. Greater than or equal to k? Yes. So I am shrinking the window. Then I got 4. But if you see clearly, I missed something. If you see clearly, I missed something, which is this window. I'll tell you what, which is this window, right? We missed this window completely, right? So I'll tell you what to do when you got a subarray which is valid. I'll tell you now. When you got a valid subarray, then we need to do something, which is we need to add r minus l plus 1. Why? Because 2 comma 1. Now what I am saying is something like, okay, now I got 2 comma 1, right? I am saying that this adding 2. Now how do I say that? Why? Because this is my valid subarray and this is another valid subarray. Now let us see for another example, something like 1 1 and then 1 and k is given as 5. So it is given in the description. Now I got, okay, wait a second, sorry, I got the whole subarray as valid. Why? Because, sorry, it's not valid, right? I am just taking this subarray. Now I am taking this subarray and let me just change it to 10. I am just changing it to 10. Now let us see what are the valid subarrays. If I took the whole array, that means I am taking this, considering this as a subarray. Now I have the sum as 3. 3 into 3 is 9, which is lesser than k. Now what are the valid subarrays even now in this subarray? It is this subarray. I am telling you this subarray and this subarray, right? And if I need to count, this is also a subarray. Now how many subarrays did I got? 0 1, sorry, I'm writing the indices 0 1 2. So the right pointer is here, the left pointer is here. So I got 2 minus 0 plus 1 number of subarrays. That's what I am doing here. R minus, wait a second, I'll write here 0 1 2 3 4. R minus L plus 1. If I do it, I'll get, wait a second, if I do that, if I do that, 1 minus 0 is 1. 1 plus 1 is 2. So I am adding 2 to the answer. It will become 3. Okay. I think it's clear now. I just incremented. Then I got the product as 21. I got the product as 21. 4 plus 1 is 5 plus 2 is 3. Sorry, 5 plus 2 is 7. 7 into 3 is 21. Now I am having the product is greater than or equal to k. Now what I need to do is shrink it. Now I am getting 4 plus 1 is 5 plus 2 is 5 into 2 is 10, which is even greater. Now I am just shrinking the window. I just got 4, right? I just got 4, which is okay. Now what I am doing, r minus l plus 1. 2 minus 2 is 0 plus 1 is just 1. Just incremented it. Now I incremented or expanded the window. 4 plus 3 is 7 into 2 is 14. Let me write it here. 14, and which is greater than or equal to k. I'll shrink the window again. I got 3, right? I just got 3, which is the product. Now 3 is the product. R minus L plus 1. 3 minus 3 is 0 plus 1 is 1. I am just adding 3. Now I am expanding the window. 5 plus 3 is 8. 8 into 2 is 16, and 16 is greater than or equal to k. And just shrinking the window, right? And I got, wait a second, I got 5 as the product. 5 as the product. So I'm just incrementing it by r minus l plus 1. 4 minus 4 is 0 plus 1 is 1. So the answer will be 6. Now okay, I'll increment the right pointer. I am expanding the window. I just got out of bounds, and 6 will be my answer. Now let me write the algorithm. But to get the product, when we are what I need to say, the shrinking. When we need to shrink, we need to divisible something I need to do uh, to remove this element from the product. So instead I just take the sum instead of the product. Algorithm is something like sum is 0, r is 0, l is 0, and answer is 0. That's it. Now while my r is lesser than n and n is, sorry, I forgot to initialize, n is uh, n is equal to nums dot size r, while r is lesser than n, what I am doing, sum plus is equal to nums of r, right? R plus plus. Now wait a second, while L is lesser than or equal to r, ampersand ampersand, nothing but and sum into what is the product. I'm just writing product r minus l plus 1 should be lesser than k. But if it is greater than or equal to k, I'm just shrinking the window. Sum minus is equal to nums of l. Then I am incrementing l plus plus, right? Okay, wait a second, sorry. So l plus plus, I did it, and then I'm incrementing r. I think it's clear for now. Then here, when we got it, the answer will be incremented by r minus l plus 1. Then return answer. That's it. I think it's clear for now. It's a simple sliding window problem. Just you need to realize this r minus l plus 1. I think it's clear for now. Now I also explained you that how you are getting three subarrays when you got a valid subarray. I think it's clear for now. And if you like this, sorry, it's not this subarray, this subarray. And if you like this video, do share it to your friends and do subscribe to the channel. And I have given the code link in the description. Go and check it. Thank you.